Hello everyone. So there's not so many of you today, probably because of the rain. So props to you if you made it here. Okay. So a few announcements before we get started. There's going to be, actually, before we get started with this, you need to do the attendance quiz. So if you go on Relate really quick and do the quiz, and we'll do it with you.
I cannot open it. Yeah, we can. Seriously? It's.
Okay, just give it a sec.
No. Oh. Yeah, I know. Okay, try again now.
Okay, is it working? Okay, good. Okay. I like this answer. Excuse me. I did well. I think this is good. I mean, you took my questions.
Yeah. There's a lot open to
They're very simple.
There's a lot open to interpretation.
Okay, so if you guys are done with the attendance quiz, so there are office hours again this week, 11:05, 7 to 8 p.m. If you're having trouble with the homework, and the homework format is slightly different this week, so and all following weeks. So if you're having trouble with that, make sure to stop by and get help. And we're going to have Andrew talk about how to access the homework this week.
Hi, so instead of being on Relate, you will start this homework by following a GitHub Classroom link, which we'll post on Piazza. So once you have the link, just click Accept this assignment. And I see GitHub does not want to cooperate today. Let's see. Okay, so you'll click Accept this assignment. Why are you doing this? Okay, so about 50% of the time this will fail because GitHub Classroom really hates us. But if this were to work, it would eventually create a repo and then you would just clone the repo as normal, and you would fill out the homework3.py file. And there are 5 functions to complete it.
Okay, yeah, and so, sorry this didn't work. We'll post instructions on Piazza, so if you're confused, just check that out. They'll be really detailed, so you guys shouldn't have too much trouble. And if you do, just make sure to drop by office hours. Okay, so the next thing is Microsoft is coming in to talk next week. So they're going to give a short workshop on Azure. So that'll be like one of the micro lectures for next week. So definitely make sure you're there. It'll be really interesting. So yeah. Okay, so you guys had your first group meeting this week. So make sure to talk to us if you're having any concerns, logistical concerns or some other problems with your group. Make sure we get those sorted out. And yeah, does anybody have any comments about like their group meetings or like how they felt, how you feel things are going in general? Anything? Just going pretty well. It's the first week, so you're probably still trying to figure out like what you're doing and what kinds of technologies you're going to use. Okay, so since you had your first project meeting, your grades for that will be up on Relate by Thursday. So if you don't understand why you got the grade you got, you can go ahead and email your PM or message them on Slack, and they can explain to you why. This shouldn't be hard. If you show up and you participate during the meeting and in the future you write code and it's good quality code, you should be fine for this grade. So as long as you're doing things that we're teaching you and you, like if you get a bad grade, ask your PM like what you can do better, and like it won't be hard to improve. Okay, the next thing, this is coming up in a couple of weeks, so just be aware of this, midterms. They're not going to be like your normal midterm, it's going to be interview style. So we're basically going to assign you a staff member, and then you're going to be in a room with the whiteboard. You're going to be given 3 interview problems, and then so coding problems, and then you're going to do those. So it sounds a little scary, it's not that scary. We have a way of grading this so that like as long as you try and you talk through the problem and you get close to the solution, you'll get most of the points. So it's not something to worry about. And we'll do a little demo probably next week just to show you like how it works. The primary thing is that you talk through what you're doing. You think through what you're doing. And so a lot of you aren't CS majors. You might think like this isn't really important, like this doesn't really matter to me, this is like a CS thing, but it's actually just really good practice to be able to think on your feet. So being able to explain what you're doing as you're thinking and think quickly is really important. So this is valuable to pretty much anybody. So it's going to be the week before spring break. Okay, and then the week after spring break, we're going to have 2 things. So during lecture, we're going to have midterm presentations where your groups will come up and you're going to present on what you've done so far. So it's pretty informal. You're just going to kind of talk about what you've done, maybe demo. There's not that many of you, so you can probably demo if you have time, and just show us like what you've worked on so far. This is also a really good time to check in and kind of see like what you have left before final presentations. So if you get to this point and you're kind of feeling like, hey, we don't really have that much together, then you know it's time to kind of like buckle down and like get stuff done. Yeah, and so that same week we're going to have the second hackathon. It's going to be on that Thursday, March 29th from 6 to 9. So a lot of people expressed that they didn't really like having the hackathon on Saturday and they didn't like how early it was. So we're trying to make things more fun this time, having it at night, and we're also going to have, so we're going to have food again. We're going to have insomnia at 8. And then one thing that we're working on but hasn't been finalized is having some sort of fun event for you guys, like halfway through. So one thing we might do is have VR demos, so you guys can like demo some of the different VR things, maybe go up to the VR lab and just like be able to play some games and stuff, so that'd be really fun. Alright, so if you have any questions, you can email me or Vivek. Yeah, don't hesitate to ask if you have any problems or you need to be excused from class, and that's pretty much it. So Vivek is going to give the Python lecture this week, and it's on Dictionaries, so.
All right, can you all read what's up there? Yes? Awesome. So today we'll be talking about dictionaries, and you might know these from other languages as being like called hash maps. Python calls these dictionaries, and essentially they're the same thing. They're pretty much a key value store. So essentially what that looks like is you have a key, and that key points to a certain value. And they don't have to always be of the same type, so they can be, an int, but the value is a string. And the important part is that, I guess how they're different from a list is that a dictionary can be in any random order. It's not ordered, and they're pretty useful for a lot of applications that you'll see more and more of later in the semester. So let's get started. So. The syntax would be kind of familiar to most of you, I guess, but let's try this first. So all right, we won't die. We're good. Let's keep learning. All right, so pretty much there are multiple ways of setting up your dictionary. One of them is just simply assign, so just say this, and that creates your dictionary with the name mydict. You could also set it up with values inside it when you do that. So you can say, so you can map the key hello to the value world. And then also you can map the number 1 to the value true. So if we do this and we, here, let me add some statements to this. And if I run that, you'll see that I added, that it printed the values that in that dictionary, which is so the key hello points to the world, and the value 1 maps to true. And so you can also set the value associated with a certain key, just like this. So just like how you access indices in a list to set it and set the values to what you want, you can do the same thing in a dictionary. You pretty much for a certain given key in this case, you assign it to a certain value, as value. So we run this. And then on the next line, we try and access the value that was in key. What do you think we'll get? There's candy if you try. Yeah, go for it.
Value?
Okay, yeah, come on up. You can still get one, sure. So yeah, you do get the string value. So yeah, and then you can also do kind of other operations on it, just like you would in a list. So let's say you wanted to check if let's say you were given a key or a value. You can check if that key or value is in the dictionary. So you would do something like this, and this would pretty much give you true because the word hello is in fact in the dictionary. So and then this you can access. You can use that there to search only within the keys in the dictionary. So run it, get true, and then this we would also get true. But if we flip this way, and run it again, we would get false because hello is not a value; it's only a key. So is that making sense so far? Yeah, awesome. And then, all right, what do you guys think this block of code does? I know it kind of says it on the top, and all of you can read, but yeah, candy. Yeah, go for it.
It checks the keys in the dictionary.
Sure, awesome. You can come get candy, or if you don't want it. No, I wouldn't throw it at them. Allegra would throw it at them, but not me. I'll miss. yeah, so if we run this, it says, yes, the key hello is in fact in the dictionary. And you can also check if something is not in the dictionary, similar to how you would do for any other operation in Python. You say, like, if that key is not in the dictionary, which we know it's not, you print what it is supposed to print. You can also do operations to check how many elements are in your dictionary. So you do a simple len, similar to how you would do for a string. We have 3 in our dictionary right now, so it prints 3. And then the most crucial part is that you can also, just like a list, you can iterate through it. So you can say, and do all of you understand what the for in does? Yes, we went over this. So for key in the dictionary, it pretty much prints all the keys and all the keys, all the values, and that is what the dictionary looks like right now. So as you saw, the length is 3 because there's 3 key value pairs. The important thing to recognize is that in a list, if you had the list with all of those strings in it, that would give you 6 because there's 6 individual elements in there. But in the dictionary, that's just 3 key value pairs. So the length is then going to be 3. You can also loop through and print, well, essentially does the same thing, just you're looping through each key and value. So notice how you're going for key comma value in your dictionary.items. Items is another way to pretty much access what's inside it. So let's try this. What do you guys think will happen if I do this? Will it work? Will it compile? Will it break? Will it give me the same result?
Same.
Same? Sure? Okay, let's try it. Not really, but you can still get candy if you want. Yeah, no. So that gives you an error because you can only do the for in if you're sure. What's your?
I was wondering, why'd you have to convert them to strings, the key and value to print?
Good question. We'll talk more about that. But so here, this is more to do with the print statement itself. So if we try printing that, and and you run that, it did one of them, but it doesn't know what. So key is a value right now, or it's an int, and so pretty much this is just to make sure that all the things that we're printing are the same thing. And so, because right now you're trying to, it thinks that you're trying to add an integer to a string.
Okay.
Right? That makes sense?
Yeah, I see what you mean.
Okay. And then of course, if you put stuff in, you can also take it out. So you can access the value at the first index and delete that, and then you can also delete things like by specific keys or values. And that. All right, one more chance for you guys to get candy. What does this do? I don't know why it says it on the top, but it says it on the top. So, sure.
Does it maybe iterate again over dictionary true with that?
Yeah, exactly. So, right. So there's just the string key and value in there. All right, so I guess some more like the applications of dictionaries, right? So what is the point, like why just not use a list? Why is this important? Why do programmers use this a lot? And pretty much the most important part, and you guys will learn more about big O and sort of efficiency later on, but dictionaries are very efficient. It takes very little time to access and delete and find values inside a dictionary because the way it's implemented is a hash map, and those are super efficient. You will learn if you continue taking CS classes more about how they work in CS225 later on. But if you're interested, you can always come up to us after class and we can talk about that. But yeah, this says it right here, which is, you know, if you have a lot of, if you have like a super big list and you go through it, then it would be looking up a certain key value pair would be a lot quicker in a hash map than it would be in a list. So this is I guess a little more like a longer problem, but I want you guys to look at it for a couple seconds and think about what this does. So you will see a little bit, you'll see some new stuff in there, which is like what is a tuple. So just think about it. If someone knows what it's doing, that's awesome, but we'll go through it anyway. Yeah, so I guess if someone can tell me what this will output, that would be great. But take your time. It's a little tricky. So we want to guess? Sure.
It's gonna output the list 2 with the 5 in the end, isn't it?
List 2 with 5 in the end. Are you sure? Let's try. Not really, but
Yeah, I did.
list 2 with, or I guess, yeah, list 2 with you and then 5 in the end, sure. No, I thought you meant something else, but yeah, so pretty much, you know, it went through both the lists, it assigned the key 1 to that, it assigned the value 2, or assigned the value 2 as a key to the other list, and then appended 5 at the end. And so does everyone get what that was doing? Yes? Awesome. Let's go through an example problem that uses dictionaries. So let's say you have a string, right? And pretty much the goal of the problem is to kind of like return a dictionary that maps the number of times each character occurs in that string. So if you had the string just like, or I guess there is an example right there, but if you had the string hello, for example, you would do H1, E1, L2, O0. And it's already up there, but don't look at it and think about how you would do it for a second, because and think about how you would use a dictionary in your solution, how that could be, because you have to return a dictionary at the end of it. But we'll go through it line by line after. Yeah, we can go through it. So so pretty much we have your function declaration here, and then this is pretty much setting up an empty dictionary, and then you're looping through every single character in your input string, and then if it's not in the dictionary already, you kind of assign the count to 1, which means if you see a character for the first time, you are seeing it once, effectively, right? So you assign the thing to 1, and then if it's already been seen once, you just pretty much increment the value of the number of times it's been seen. So L in this case would be seen twice, and so you're pretty much, so you're just accessing, you're setting the key of that to be a certain value, and then you're setting the value as well. So let's run that, and then also run that. Does output look good to all of you? L twice, H, E, and then, yeah. String up here. So yeah, this is probably going to be on your next homework. Not this exact problem, maybe not, but something to do with dictionaries. So post on Piazza, or let us know if you have trouble with it, or come to office hours. It's not a super hard concept to grasp, and crucially, it's a very useful one. A lot of applications. So yeah, pretty much, I guess, dictionaries for you. Let's. Up next, we have Aubrey, member of course staff, who will talk to you about web dev and some of those things. Sure.
Hello? It's on? All right. Hello, everybody. I'm Alpri. I'm a freshman in pre-engineering under DJS. I'm trying to go CS. So today, or tonight, I guess.
Can you all hear? It's fine. Yeah.
Good? All right. Alright. I'm just not used to this. All right. So today I'm giving a lecture about web development. I'm actually I want to distinguish against different types of web development. So I'm giving a lecture about front-end web development, which mainly focuses on the design aspect and pretty much what the end user sees. So there's also back-end development, which I was told you guys will get a micro lecture on later in the year or later in the semester, and that kind of deals with data processing in the back end. This is just kind of rendering a site to a client. So there's three main parts to front-end web development. There's HTML, which kind of structures a document so the computer knows how to render a site. CSS, which styles the document so your website actually looks nice. And JavaScript, which makes your site interactive. So I'm going to start with HTML. It stands for Hypertext Markup Language. And to understand HTML conceptually, I'm going to focus on the markup aspect of HTML. So let's actually just look at a regular document. So I just drafted this up. So if we wanted to look at this document and kind of just go through and label the different parts of this document, we have a header, we have some sort of paragraph in there, we have text that's italic, there's some bold text, there's some sort of list, and then at the end we have an image. Intuitively, we know that we could look at this and know what each part of this document is, but how do we tell a computer what part is what? How could we mark up this document so that a computer knows how to render it? So one way would just to be labeling every single aspect of it. So I just happen to use something that kind of looks like HTML, but this is conceptually what HTML is. It's just labeling each part of your document so that a computer knows what part is what, so it knows how to render a site. So this is completely arbitrary. I want to emphasize that. I could have picked anything. I could pick, I don't know, squigglies instead of carrots. I could have named this a title instead. And this is actually really close to what HTML actually is. So on the left we have the previous slide, and on the right we have actual HTML. So this is what you would actually put into your HTML document and have a site be rendered. So there's a few key differences. At the top, we have something called a Doctype HTML. So basically, at the top, you're just specifying that this document is an HTML file. Nowadays, though, as long as you have a file extension that's .html at the end, you honestly don't need Doctype HTML. Most browsers will work perfectly fine if you don't put that. Then you have an HTML tag at the beginning, followed by a body tag. So your body tag is where all of your content actually goes in a website. So if we actually look, instead of header, I have something called H2. So this kind of shortened, or this is abbreviated for kind of header level 2. So HTML actually has 6 levels of headers. So H1 would be, I guess, the biggest size. You could specify the relative size, like H1 and H2, they're just relative sizes. It does not correspond to an actual font size. You could actually define that yourself. But H1 is the largest header type, and then H6 is the smallest. Next, I labeled the paragraph. So one thing I want to point out is also, unlike the arbitrarily defined labels that we put on the last one, or the last document, you actually have to do an end tag, which you specify with a /. We did, instead of italics, it's just an I. This tag is called a division tag. So if you want to divide your content into different sections, you use div tags. Next, we have another paragraph tag, and then bold is usually, you could arbitrarily define boldness with CSS, but with HTML, you could just use strong tags. Next, we have a list, which is OL, or unordered list. There's also something called unordered list in HTML, which are just bulleted lists. Ordered lists actually have the numbers on the side. And then each LI is actually abbreviated for list item. So if you wanted to make a list, you actually have to specify each single item in that list. And last, we have the image tag at the bottom, which specifies our image and where it actually is. So if you haven't noticed yet, there's actually no end closing tag. This is all one tag. And there's a few tags like this in HTML, where it's a self-closing tag and you just have a / at the end. Also, notice that there's something called source here at the bottom. Oh, this thing keeps popping up. All right, I guess I just won't move the mouse. All right. So there's something called source at the bottom, src. So that's called a property of an HTML tag. And what follows is the value that's in the quotes is actually the file path to the image. So if you want to make an image appear on your site, all you do is make an image tag and then put the file name within the source. So kind of like just emphasizing what I've been kind of saying already, is that HTML tags kind of follow this common structure, where you have a tag name with an ending tag at the end with a /, and you could have properties with values too, with your content in between your tags. So we kind of looked at a few of these tags in the last example, but HTML actually has a lot of tags, and it would be unrealistic for us to go through every single tag in this one lecture. So it's best to just know the general format of how tags are used in HTML. If you could pretty much Google like every single one of these tags, and there's a lot more than the ones up here. So it's kind of pointless to try to memorize every single one of them, honestly. So next I want to talk a little bit about CSS, which stands for Cascading Style Sheets. So to repeat what I said in the beginning, these are used to style your website so they actually look nice, unlike that website. So CSS actually has a lot of functionality. It has a lot of basic styling stuff, so background color, font, text, but you could also do a lot more advanced functionality with CSS. You could do advanced layouts using grid systems, and pretty much you could program a whole grid system with pixels, and it'll calculate how many columns. It gets complex. You could do animations with CSS with newer browsers. You could have gradients, and then does anyone here know what a SVG is? All right, so a few people. You could actually generate SVG images using just CSS too. And also you could have responsive web design. So if you want your website to look nice on both mobile and desktop platforms, you could code that up in CSS without having to do any JavaScript, and it'll be responsive. So conceptually, how to use CSS can be broken down into a single sentence. You use CSS to select HTML elements, assigning values to different style properties. And one thing I want to touch on before we get into the syntax is there's actually two other ways to select HTML elements. So you could select HTML elements by their tag names. So the tag names we've seen already, so paragraph, division, and other stuff like that. But if you want to select a group of elements that spans across tag names, you could use something called a class. And class, by the way, is a property that you would assign to the HTML element. You would use ID if you want to use CSS on a single HTML element. And this is how it would look like in actual HTML. So this is actual CSS syntax. So first, you label your selector with kind of like an open brace, I think it's called. And then you have a list of properties and values, which are different from your HTML properties. These are style properties within CSS. One thing I want to note on is you're actually separated, like it's not an object. So you're actually separating them by semicolons, not commas. So let's take a look at a few examples. So if you want to style every H2 HTML element, this is how you do it. You just put H2 followed by the syntax shown, and then pretty much just put properties followed by the value you want to give them. If you want to select every single element in a class, you would prepend a dot before the class name and do the same thing. If you want to select elements using IDs, you'd use a hashtag before the IDs. Does anyone have any questions at this point? No? All right. Good on. So I'm going to actually try to demo using HTML and CSS. Anyone see that? Oh, that's kind of small. All right, can everyone like remotely read it? People in the back? It's good? All right. So this is actually the document that I kind of used as an example earlier, and I kind of converted it into HTML. So if we want to look at this, it's the same exact HTML that I showed earlier, except it doesn't have the body tags or anything, because that's just how this website works. So one thing I did add is a class called content, and I added that to a few of the paragraph tags. And then I added an ID to one of the list items. So I'm going to go ahead and style this document. Since we don't have that much time, I'm just going to, it's probably going to look like trash, but I'll add a color to every single content class HTML element. So really easily, you can see already that all of the HTML elements that have the class called content are now red, just with a few lines of code. And now I'm going to do something similar with ID. So let's do background color. So now, as you can see, the HTML element with an ID called the question has a background color of blue. I do want to mention CSS has a few preloaded colors, so like red, green, blue, like Roy G. Biv colors. But you could actually specify like specific colors. So if I go ahead and do like, it's called hex, hex encoded colors. So if you do something like, I don't know, 660000, I don't know what color that is. Oh, that's still red. Okay. Let's do, I don't know, 0, 0. So now it's green. So you have a lot of choice when it comes to colors. You could also do gradients. It's a little bit more complex. I can't even do that off the top of my head. And then let's do one example of adding an image. So if you actually look, like this huge image is like just a link that I found. So I'm just gonna go ahead and find an image on Google and put it in our site. So with a few lines of code, I'm able to add an image to a site. One thing I do want to mention though is, since I'm just using like links from Google, like it works, but when you actually make your own website, usually you have your image locally and you just put your file path. So this is going to break the code, but you would do like /, and then I don't know, like meme.jpg. So that's how you'd actually do it when you have the image locally on your computer. Does anyone have any questions at this point? Everyone good? All right. So just to recap on HTML and CSS before I move on to JavaScript. HTML structures a document so that it could be rendered, and CSS defines styles so that your rendered site actually looks pretty. But what if you actually want an interactive site that responsively reacts to user input? Use JavaScript. Spoilers. One key difference though is JavaScript is not Java. It does have a lot of the same functionality that any regular programming language has, so it is still really powerful. And since you guys know Python, it's actually really easy to know how JavaScript works. So let's look at an example. So on the left we have Python, and on the right we have JavaScript. So I guess for candy, can anyone tell me what the code on the left does? I'll up the stakes for 2 pieces of candy. You in the back?
I think it uses the for loop to put, we go from 0 to 10, puts each of them in y and prints out y.
Alright, you can come up to get your 2 pieces of candy if you want. So that was really close. So the way that range kind of works, it actually goes from 0 to 9. So it'll print out 0 to 9, and then it'll actually put 1 to 10 into the list, and then print those out. I didn't have enough room, so yeah. Can anyone guess what, oh well, you already could see, but code on the right does the same exact thing. So I just want to point out a few key differences between Python and JavaScript. So one thing you'll notice is that you actually have to explicitly declare variables. So you have to say var x. There's a few other keywords in JavaScript that let you kind of fine-tune what kind of variable you want. So you could say let x equals 10. There's also something like const x equals 10, and basically, I'm not sure what let does, but const basically makes, pretty much sets the variable so that it doesn't change throughout your whole program. One thing, if you're coming from a language like C++ or Java, you don't have to specify types. So in Java, you'd have to do like int 10 or int x equals 10. You don't have to do that in JavaScript, but you do have to explicitly say it's a variable. Also, you have to put semicolons at the end of each line, unlike Python, which actually could be a pain. Sometimes you'll run into runtime issues or compiling issues because you don't have a semicolon. That's kind of annoying. For loops, if you're coming from Java, they look pretty much exactly the same as a for loop in Java, other than the keyword var. So pretty much instead of int, you just have var, and it's the same exact syntax as JavaScript, where you have an initializer, where you basically specify variables you want to initiate. You have, I forgot what these are called, but it pretty much goes until this goes false, and then this is your increment. So each time you're incrementing I by 1, and then you're checking it against x to see if it's greater than. Another thing I want to point out is JavaScript allows you to pass functions between functions. So this is kind of a more advanced topic, I guess. But this weird arrow notation is actually another function. So what I'm doing is iterating through y, and basically each time it has an element, it'll call this function, which just prints out e. Because JavaScript doesn't have an easy syntax like e and y to do like it's called an enhanced for loop if you guys are coming from 125. But what you guys might be wondering is like, if Python and JavaScript are so similar, why can't we just use Python for front-end web development? One of the reasons is that there's JavaScript-specific functionality that exposes an object called document to JavaScript. So this actually exposes the document object model. It's a fancy word for pretty much you could access HTML elements through JavaScript. So can anyone guess what script.js will do? You in the back.
It will get the H1 element by its ID, which is heading, and then we'll set the value to how many go.
Yeah, exactly. So by running this, it'll actually get this element by its ID name, and then it'll access the inner HTML, so the HTML or the content within these tags, and set it to hello world. There's a lot of these actually. There's like get element by class. You could pretty much do a lot of things, and there's like libraries that make it easier to do this. So key points of JavaScript. It's actually JavaScript ES7. I forgot to change this. Like JavaScript gets updated a lot, so it's like an ES7 now. JavaScript is object-oriented, so just like Java and Python and pretty much every other languages, you could apply the same don't repeat yourself strategy to solving problems. You could run JavaScript as a standalone application, which means you don't necessarily have to run JavaScript within a browser. Does anyone here use Atom text editor? All right, so a few people do. That's actually completely built off JavaScript on a framework called Electron. So that's actually based off JavaScript. And JavaScript is really relevant for computer science. If you're going into web development or want to move to Silicon Valley at any time, you're going to have to learn JavaScript at one point. A lot of companies are actually moving to a JavaScript-based tech stack, which basically means everything from front-end web development to back-end web development is all JavaScript-based. Instead of having to learn multiple languages, they're hiring employees who just know JavaScript because that's their whole tech stack. And then, how do I start making a project? So if you're just making a simple project with one page, this is how it's pretty much going to look. So in your folder, you're going to have whatever your folder name is, and then you're going to have something called index.html, styles.css, and script.js. So you could label these files anything you want, but canonically, it's usually index.html that marks the root of your website. And then, as you saw earlier, like with the HTML, you still have to do the doctype and the HTML tags. So this is actually new. You guys haven't seen this yet. So your head tag is special. So this is where you want to load in all your style sheets. And also there's you could load in all the metadata for your website. So metadata would include, like, if you want to put like an author name on your website, you would put it there. You could put like viewports, like it's for CSS stuff. There's a lot of things you could do, and usually you also load in your JavaScript at the end of your HTML, just because JavaScript takes a while to load, and you usually want your HTML to load before your JavaScript. So what if you want to learn more about front-end web development? What I used when I was learning a lot was Codecademy. Codecademy is actually free, and it's interactive lessons where you basically type out HTML, CSS, and JavaScript. They have a lot of stuff. You could learn anything from front-end frameworks like React to back-end stuff like Express.js. And W3 Schools is pretty much the Wikipedia for front-end or web development in general. You could go on there, and they pretty much have a list of every single tag and what it does. And if you're really into JavaScript, there's a few things you might want to check out. So if you're into building web applications, so if you want to be the next millionaire and make the next Facebook, you really want to learn React. React is a really good framework for structuring larger applications that would otherwise be impossible to data manage. If you want to make a game, what's actually really cool about JavaScript is that you can deploy on multiple platforms. So you could write your code once and deploy on Android, iPhone, and web. So you could use something called Phaser.js, which is really beginner friendly. They have a lot of resources you can use. And if you want to just run JavaScript locally, like on a terminal, you could use Node.js. And yeah, that's my whole lecture on front-end web development. Thanks. If you guys have any questions, I'm going to stay after lecture, so you guys can come talk to me if you have any questions.
Okay, yeah, so that's pretty much it. Yeah, if you have any questions, come up here and ask. That's it for this week. Make sure you do the homework. That'll be due next week. And if you have any questions about the homework, go to office hours. Yeah, have a great week.